Right. Has anybody got another one in your homework that you want to see work? All right, well, let me get you to work me one then. All right, find this for me. So what if I gave you this one on a test? Let's see. Find the slope of the tangent line to y equals x squared minus 5x at the point 1, -3. All right, find me the slope of the tangent line to that parabola at the point 1, -3. Now, do we understand that these are two ways of asking you the same thing on the test? So the slope of the tangent line is the same thing as the what? The derivative. So you gotta know what you're being asked so you know what to do. So if I tell you to find the derivative, you're gonna use that formula. If I tell you to find the slope of the tangent line, I'm using that. Because they're the same thing. Now, if f of x is x squared minus 5x, what does f of x plus h mean for me to do? What's x getting replaced with? X plus h. So that x and that x are both going to get replaced with x plus h. Does that make sense to everybody? So when I square x plus h, I'm going to get x squared plus 2xh plus h squared. And then make sure you distribute that minus. So it's minus 5x. Is it plus or minus 5h? You tell me. Minus. Now, there's nothing that I can do to make that look any better. There are no like variables there. All right. So does everybody understand that this f of x plus h is this all this stuff right here? So I've got an x squared, a 2xh, an h squared minus a 5x minus a 5h. So that's my f of x plus h. And it says minus, so I put minus. All right, now I've got to write down f of x. Well, what's f of x? Well, f of x is the same thing as y. So my f of x is my x squared what? Minus 5x. And then all that is over h. Okay. So I've got the limit as h approaches 0. That first bracket's not doing me any good, so I can just drop it off. It's the same with or without that grouping. But if I don't have that second grouping, my signs are going to be incorrect after the first one. So I'm going to have a minus x squared and what kind of 5x? All right, so plus 5x. Now I'm going to clean it up. Does anything go out? The x squareds go out. Anything else? The 5x's go out. All right, so let's see what that leaves us. So I've got a 2xh, I've got an h squared, and I've got a minus a 5h. Everybody okay? Now, what can I factor out of this numerator? What do all those have in common? H. So when I factor that h out, what's that going to leave in this first one? 2x. What do you multiply h by to get h squared? H, and then a minus what? Now again, what goes out? The h's go out. I'm not going to make you write me that note anymore since you wrote it on your first test. So I've got the limit as h approaches 0, and I've got a 2x plus an h minus a 5. So now can I take 0 and plug it in for h? So I've got 2x plus 0 minus 5. So what do I get? I get 2x what? Minus 5. There's my derivative. That's my general derivative. That'll get me the slope at any particular x value, any particular point. So if they just want the general derivative, I would quit. But they didn't want the general derivative. They wanted the slope of the tangent line at the point 1, negative 3. So what am I about to put in for x? 1. So I didn't. Now, it's not negative 3 because that's negative. That's just a coincidence. Everybody okay? So there's the slope of that tangent line. Are we okay? Now, the problem with doing it with the definition is it gets nasty. Because if you've got something like maybe your function is 6x to the 7th minus the cube root of x plus pi. I mean, you see what I'm saying? I don't really want to have to do x plus h to the 7th power. And what am I going to do with this x plus h to the 1/3? You see what I'm saying? So it gets kind of sticky algebraically when you start doing it in with the definition exclusively. So what we're going to get today is we're going to get some theorems. Now, if you don't learn these rules, you're going to have to do it that way on the test for every problem, and it'll be an algebraic nightmare. All right, so when we go over these rules, I would know these rules before I came back into class next time. Okay, so that saves us from having to do this derivative definition on every single problem that we do. All right, so let's go get some shortcuts. Let's go get some derivative rules. Now, what happens sometimes is students get limits confused with derivatives. So, do we remember that limits are y values? Okay, so when it says something like, what's the limit of x squared as x approaches 3? What that means is on the graph of y equals x squared, when x is getting closer and closer to 3, is y getting closer to anything. but derivatives are slopes of lines. So they're not the same thing. So the reason I say that is this. All right, now, here's another way of writing derivative, all right? If they put f of x equals x squared, they might say f prime of x. That's one way of saying find the derivative of that. Sometimes though, the thing's not named. So what do I mean by that? Sometimes they'll just say do this. Take the derivative of x squared. So instead of naming x squared a name, they just said take the derivative of what? X squared. Now, this d to dx, another thing they'll do sometimes is this. If it says y equals x squared, they can put y prime, or sometimes they'll put dy over dx. They're just different notations. What this would tell you is your thing is named y, but the variable in there is what? X. So when you're looking at this, they're saying the derivative, take the derivative of this thing and your variable's x. Now, right now, that seems kind of silly. You're like, well, sure, it's x. But when you get to higher calculuses, there'll be more than one variable in the same problem. So they've got to tell you which one you're looking at right now. In other words, if I had some, 2xyz plus z cubed minus 2xy plus y to the third, which one's my variable? So if they tell me to take the derivative of this thing with respect to x, that means I pretend like y and z are constants. If they tell me to take the derivative with respect to z, well now x and y are constants. So right now this seems a little silly, but it will make more sense later. All right, with that said, the derivative of a constant. Now by constant, you understand I mean a number. All right, so in your book, these rules basically start on page 130. Now let me ask you this. This would be an example. Y equals 3. So what's the derivative? Well, the derivative of a constant is 0. Now, we'll talk about y in a second. What does the graph y equals 3 look like? Is it a parabola? What's y equals 3? What kind of line is it? Horizontal. So we understand that 3 units up, you have a horizontal line here. Now here's what I mean by I don't want you to get derivatives confused with limits. What's the limit of 3 as x approaches any number? What's the limit of a constant? It's the what? The constant. Because what it's asking you is, like on this one, it's saying when you get close to 2, what's your y getting close to? Well, on this graph, y's not just getting close to, y is always exactly what number? 3. But derivatives aren't y values, they're slope. What's the slope of that line? 0. That's why the derivative of a constant, the limit of a constant is that constant, but the derivative of a constant is 0. So if the graph is a line itself, you're finding the derivative of that line. Okay? Now, here's another rule you need to learn. So the derivative of that would be 0. Now, suppose you have something to a variable. So that would be something like this. Example. Y is x squared. Find the derivative of y. So that is a letter to a number. Now, we're kind of pressed for time since we were out for a week, basically with snow. Is everybody with me? So the book does a pretty good job of showing you the proofs of things. I'm not gonna have time to do a lot of proofs. I'll show you a proof of something in a second that's real fast. But the book's pretty good. Here's the rule. The power comes down and becomes the coefficient. The variable stays the same, and the power goes down by 1. So I've got to learn that rule. So what's going to be the derivative of x squared? What's going to happen to this 2? It comes what? It comes down. So the coefficient's a 2. The variable x stays what? Stays x. What happens to my power? It goes down by 1. So what is 2 minus 1? 1. So the derivative of x squared is just 2 what? 2x. What would be the derivative of, what if you add x to the 4th? What would the derivative of that be? 4x cubed. Because the power comes down, the variable stays the same, and the power goes down by 1. Now, sometimes it's kind of hidden. Here's what I mean by hidden. What if you had the square root of x? That's right, I'm going to have to change that and make it x to the 1/2. So I've got to be able to rewrite it to see that I have a power. So what would my derivative be? What would happen to that 1/2? You come down front. What would happen to that variable? It stayed the same. Now what happens to this power? That's right, so 1/2 minus 1 will be 1/2 minus what? 2/2. So that's going to give me a what? -1/2. Now, we don't like leaving powers negative. So that's not what they're going to have in the back of the book. They're going to bring that to the bottom and make it 1 over x to the what? 1/2. Now, you can leave it like this if you want to. But the back of the book's probably not going to leave it like that. Since it gave it to you as a root, it's probably going to have the answer in the back as a root. So what's the same thing as x to the 1/2? That's probably what they would have in the back of the book. And if I've got to plug a number in, I'd rather plug a number into that than that. Okay? So sometimes this power rule is a little hidden. All right, here's another one that might be a little hidden. Suppose you had 1 over x. Is there a way to write that as a power? What happens when you take this and you bring it up? So that's x to the -1. Now can I take the derivative? So what would happen to that -1? It would come to the front. My variable would stay the same. Okay, what's a -1 minus another 1 going to get me? A -2. Now again, they don't like negative exponents. So that -1 is fine, but they're going to move this x to the -2 to the denominator, make it x to the what? There's my derivative. So sometimes this power rule is going to be a little bit hidden. Okay? So you may have to play some algebra before you can use it. Sometimes you can just straight up use it, but sometimes it's a little hidden. So if you've got roots, those are probably going to get changed to powers. If you've got fractions right now, they may get changed to powers. Are we okay? Now, let me show you something else before I move to the next one. What if you had x over, let's say x squared plus 3 over x? What am I going to do with that one? Well, again, I'm going to have to play algebra. Can I put x squared over x plus 3 over x? Is that algebraically the same thing as that? Yeah, because when you have a common denominator, wouldn't you keep that common denominator and add those numerators? Well, won't that simplify? What is x squared divided by x going to give me? x. And then again, can I take this x and move it up? So that'd be 3x to the what? Negative 1. Now I'm gonna give you another theorem that helps us finish this one. Okay, so sometimes you may have to play algebra in order to get it to do something. Okay, and we'll work that one again in just a second. All right. Let's go get this third rule. And we'll come back and finish this one in just a second, after I give you this third rule. Okay. And here's the third rule. What if you've got a constant times a function? Well, if you've got a constant times a function, that says that you multiply by the constant first and take the derivative second. But this rule says you can change the order and do it this way. Now, let me show you what I mean, and then I'll show you this proof goes real quick. So I'll kind of do the proof real quick. What's it talking about? It's talking about something like this. What if you had a 2x cubed? So in other words, what if I told you to take the derivative of 2x cubed? Well, this is like a 2 times an x cubed. Don't I know how to do the x cubed? So this one says I can take this 2 and do 2 times the derivative of x cubed. Okay, so I can pull the 2 out. So what's the derivative of x cubed, rule number 2? What am I going to get there? 3x squared, which means what's my final answer going to be? 6x squared. Very good. So do you see, here's what it looks like is happening. When you take this 3 and you pull it down, what if there's a number already there? What are you going to end up doing with them? Multiply. Okay, and the reason that this works is this. Here's what's really happening. Now you don't have to write this down, just watch. F of x plus h means what happens up here? This x gets replaced with what? X plus h. What's your f of x? Well, my original is just c times f of x. Well, what can I do here? What can I factor out of that numerator? I can factor out of what? Can I factor out of c? And that would give me f of x plus h minus f of x all over what? H. Then I could say, well, that's the limit as h approaches 0 of c times this thing. So that's going to give me the limit of c as h approaches 0 times this limit. Well, what is that? That's just the definition of a what? Of a derivative. And what's the limit of a constant that is what? A constant, which is that rule. Okay. So in your book, they're doing proofs for all of these theorems, going back and using the what? The definition. Now, you don't have to be able to do that. You just have to know what the rule is. Okay? So, let's go back and finish this problem. All right. So we understand that right here, my derivative would be, this 3 would come down, x would stay the same, and my power would go down by 1, so we got 6x squared. All right, let's go back and work this one. So let's finish this one. If they wanted the derivative of this original problem, I would have to rewrite it like this. Well, what's my derivative? All right, well, let's figure this out. What does x mean? X to what power? When there's not a power showing what's it understood to be. A 1. So do we understand that 1 would come down, my variable would stay the same. What's my power going to turn into? What's 1 minus 1? That going to be 0? Now again, what's going to happen to this power? It comes down. My variable stays the same. What happens to my power on the power rule? I subtract 1 more, don't I? So I'm going to get a power of a negative what? Now, what's anything to the 0 power except 0 to the 0? 1. And what's 1 times 1? So do you understand that the derivative of a single variable is always going to be a 1? All right, same thing here. I'm going to get a negative 3x to the negative 2. But they're not going to like that negative exponent. So they're going to have a 1 plus, or actually plus and negative, same thing as minus. They're going to have a 3 over an x squared. And they might get a common denominator. I don't care. Okay. So does everybody understand your first 3 rules? Are we okay? All right, let's go get this 4th rule. All right. Here's rule number 4. What if, and it really, I got ahead of myself right here. What if you had an f of x plus a g of x? All right, I went back and used it over here, wasn't even paying attention. That says that you could do the derivative of the first one plus the derivative of the second one, which is what I just used a second ago before I gave you the rules. So I shouldn't have done that. So if I give you one like this, y is x squared plus 5, and I tell you to find me the derivative. I can do the derivative of this one separately and the derivative of that one separately and then add them. So what's the derivative of x squared going to be? So everybody see why it's 2x? Because your power goes down, your power comes down, it becomes your your coefficient, your variable stays the same, and when you subtract 1 from the 2, that gives me a 1. Then separately, what's the derivative of a constant? 0. So what does my derivative end up being? Just what? 2x. Now, the lovely part about this, it doesn't just work on addition, it also works on subtraction. So if there are several terms strung together with pluses and minuses, you can find the derivative of each one separately. Okay. All right, here's your 5th rule. That also works on multiplication. Okay, so you can do the derivative of the first one and then do the derivative of the second one and then multiply them. All right, and that'll end up being a little more handy later. Well, I just lied, that's not true. I'm getting ahead of myself. I'm doing limits instead of derivatives. All right, so let's take that one off. All right, let's do this one. So erase that one out of your thing. I wasn't paying attention. Now, there are 2 trig ones in this section, okay? And you're going to need to memorize these 2 trig ones, okay? If you're taking the derivative of sine x, you get cosine x. And if you take the derivative of cosine x, you get negative sine x. Now, when they come to trig, you're really better off memorizing them. So that's kind of your first set of derivative rules. All right, so here's what I want you to do for me. I'm going to give you some problems. All right, and I'm going to kind of pair you up. All right, so you're going to kind of check your answers with somebody else. Is everybody with me? All right, you got these all written down, so let's do this. And I'm going to walk around and help you if you need it. All right, Cole, you and Hiddle are going to be partners. All right, so y'all can either move kind of, but don't move your dash, just kind of get to where you can talk to each other. Maybe easier to be over here, Cole, and then you kind of talk that way rather than turn around. You two are going to be partners. You two are going to be partners, and you two are going to be partners. And the same kind of thing. It may be easier, step one, to kind of move over there and talk to her that way. I'm going to put some problems up here, and I want you to practice them. All right? So if you don't know what to do, you can help the other one out. If you do know what to do, then what I want you to do after that is compare answers. Everybody with me? All right, but you got to stay together. Doesn't mean that you work separately, silently. Okay, so here's your first one. All right, try those four. And I'm going to add one more rule before you leave. It's going to be your favorite. So try the first one, and then check your answer with your partner. If y'all don't agree, so you figure out who made a mistake, and then do the same thing. Try the second one, and then when both of y'all check your answers, if somebody, if one of you don't know how to do it, ask your partner. I'm gonna go wash this marker off my hand. I'll tell you right now.
I didn't. I missed this part.
So I used yeah, also use that.
I think that's good.
Like 1, 4, 0. I take it to 0
These are very weird.
and then the 6 squared. Probably the 6 times derivative squared. So I'm going to do that because a big one that's
I did it
so now just do like 6 times.
for the 3x. So x, like in her.
You got to check your first ones.
Yeah, 1x.
You'll be on the first one.
Or that's a 0. Or you got. What about this?
You check your first ones.
We're talking about it right now.
Okay. You got to check your first one.
I'm trying to figure out the first.
Okay, all right, so what am I gonna do with that power to bring it down? Oh, there's already a 6 there, so what are you gonna do with those two
I'm not
numbers?
sure.
Okay, so we're gonna say it like this. You can think about it like this. I can take the number and leave it alone. What's the derivative of x to the second? What happens to that?
4.
To the- So what am I gonna do with this?
Like
Bring the number down, there's already a number there, multiply.
Perhaps.
So minus x on the second of the negative.
All right, let's see what we got. Okay, here's what we can do. All right, is there one that
Oh,
says
yeah.
that if you have a fraction that's the derivative of the top over the derivative of the bottom? No. So I can't do that. That makes sense? In other words, I can't take the derivative of the top and take the derivative of the bottom. That's not a rule that I have. So I'm gonna have, I don't have a rule that's got fractions in it. Now, we'll get a one later, but that's gonna be it's gonna be a long rule, so I tend to try to avoid it anyway. So I'm gonna have to play with it and divide all of these by x squared first, and then do.
Do everything times. So like -2.
Yeah, you can do that. In other words, instead of thinking about it like division, you can think about bringing it up and making x to the negative 2 and then multiplying it out before you start. In other words, so you haven't done any calculus yet. You're just trying to get a bunch of power. So after y'all multiply it out, double check and see if you agree on what that is. That's what we're looking at now. All right, so let's see what we got. So we agreed on the 12x. All right, here's what you can't do. If you do one, you gotta do them all. You can't do one and then not do the other. Does that make sense? So you have to do them all at the same time. All right, so we did that one. Now, what's that power? That's the power of 1. So what's gonna happen to that 1? It's gonna come down, right? Well, that power is a 1, so we're gonna subtract 1 more. And then plus, all right, what's the derivative of any constant? So I'm gonna have this 12x to the first, all right, and then minus, now what's anything to the 0 power except 0 to 0?
She said, well, you can do that all.
1. So that's a 1. So what's a 1 times a 1? And then a 3 times that is 30.
I don't know, I just.
That's why I was trying to get one line.
So I've gotta multiply this out. So that means I'm gonna have to say, what's 2, whatever the exponents when I multiply.
do it first.
I'm gonna add them.
I think that's just it.
Yeah, so what's a 2 plus a negative 2 gonna do? So that's gonna be 3x to the 0. All right, but what's 3x to the 0?
Looks familiar to the
Yeah.
number.
So that's gonna be a 1. And then here, I'm gonna have, that's an x to the first and x to the negative 2. So what's a 1 plus a negative 2? Now, x, there you go.
But anytime it's just like an x, it's just one.
Anytime it's just a single letter, it would be, like if you just have x, but that's an x to the negative 1, so that's not the same thing.
Can you guard? Can you guard? 2.
For number 2, I couldn't.
See what we got, all right, so you got a couple ways of looking at it. If you put 3x squared over x squared minus x over x squared plus 1 over x. Okay, or you could take that x to the 2 and bring it up and make it x to the what? And multiply it out. But that's just doing algebra, you haven't done any calculus, you haven't done derivative yet, you're just trying to make it fit one of your rules, you've only got 6 rules. Well, it's not trig, so it can't be those 2. All right, we don't have one about division. So I've either got to make it a power rule, a constant, something like that. So would you be more likely to divide it, or would you be more likely to bring it up and multiply? Okay, then do that, put down, 3x squared minus x plus 1, and then x to the negative 2, and then multiply it out and see what
To do it like this, to do it in.
you got. You gotta do all that on words. There's not one that says the derivative of fractions, the derivative of the top of the derivative of the bottom, that's not a rule. Okay, my problem is I can't give you points for that. Does that make
Yeah, I'm
sense?
trying to think through.
Right. I mean, that's great, but I'm just saying, you're down with the grade.
So like 3x squared times x to the negative 2 is just gonna be like 3x 0. Because you should add x powers.
When you're doing multiplications, you add the exponents.
3. Minus. To the negative 1, and then.
So you have a 3, and then you have a minus x to the what? Okay, and then a plus what? What's 1 over x? Uh-huh. Now you're ready to do calculus. I mean, all that was just algebra. So you haven't done any calculus yet. All right, so there's not a rule that says the derivative of a fraction is the derivative of the top of the derivative of the bottom. There's no rule that says that. So that's not a rule, it won't work.
Would you do?
So you're gonna have to play algebra. In other words, that's what I'm saying, there is no, what you just did was this. You went and took the derivative of the top, and then you went and took the derivative of the what? That's not a calculus rule, that does not work. Okay, so what you're gonna have to do is make it fit a different rule. I've got to make this fit one of those 6 rules that was on the board. So it can't be 5 or 6, because that's trig.
No, I'm
All right.
sorry.
So what I'm gonna have to do is either this, some people are choosing to do this. And bring it up and saying x to the negative 2 and then multiplying it out. Some people are choosing to do this. That's not this. And then doing power rules. But all that's just algebra before you can do the calculus.
I'm still trying to slam my face.
All right, look up here. Where's my phone? All right, does everybody understand how you get the derivative of this first one? That 2 what? Comes down. There's already a 6 there, so what are you gonna do with those 2 numbers? So I've got 12 what? 12x. What's the derivative of this minus 3x gonna get me? Minus what? Isn't that x to the first?
Yes.
So when I bring that 1 down, 3 times 1 is 3, and that's gonna be x to what power? But what is x to the 0? It's not 0, it's what? It's 1. And then plus, what's the derivative constant? 0. So I don't really need that, so does everybody understand why? That's the derivative of the first one. Now, all of you made up a calculus rule that's not the right rule. Everybody with me?
Yes.
Like, let me tell you what's gonna happen on a quotient rule next week. The derivative of fraction is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's gonna be the rule. So we don't like to use that rule unless we have to use that rule. Is everybody with me? So that's why I tend to avoid it. It is not the derivative of the top over the derivative of the bottom. I wish it was, but it's not. So I'm gonna have to play algebra here. Now, some of you are doing this. If you move this to the top, what's that gonna be? X to the what? Negative 2. Then you have to multiply it out. So what happens to powers when you're multiplying? What do you do with them? You add them. So that's gonna be 3x to the what? 0 minus x, isn't that a 1? So what's that gonna give me? X to the what? -1, isn't it? Minus X to the what? -2. Other people were doing this. Well, what's 3x squared over x squared gonna give me? 3. In that, what do you do with when you're dividing? What do you do with your powers? Don't you subtract them? And 1 minus 2 is a -1. Couldn't you bring that one up and make it x to the what? Do you understand that this is the same as this? Now, because what's x to the 0? I haven't done any calculus. All I've done is algebra from 7th grade. So all I did was change this to this. Now, why did I change this to this? Because I know the rule for this. So if y is this, what's the derivative going to be? What's the derivative of a constant? 0. Minus, all right, what's the derivative of x to the -1? What's going to happen to the -1? It comes what? Comes down. My variable stays the same. What happens to my power? What do you do with it? You subtract 1. So what is a -1 minus 1 more? That power is going to be a what? -2. Plus, what happens to your power? It does what? Comes down. Your variable stays the same. Again, what happens to your power? You subtract 1, don't you? So what's a -2 minus 1 more? -3. And then you got to clean that up. What's minus is negative going to end up being? Positive. Now they're not going to leave it x to the -2. What's plus a negative going to be? Isn't that a minus? So how are you going to write x to the -2 so you don't have a negative exponent? Again, we're in 7th grade math. That's 1 over x what? 1 over x squared. Minus 2 over what? Now, you can leave it that way. The back of the book might even go get a common denominator. I don't know. But what you've got to do is you've got to make all of your homework problems fit 7 rules. I'm going to give you one more rule before you go. If it doesn't fit that, you can't work it yet. So you're going to have to do a lot of algebra before you can even start the calculus. So do you understand what I mean by if that algebra on that first test was eating you, it's going to keep eating you. That's not going to get any better until you get it fixed. Now, look at this one. Do you have anything about roots on any of the rules? So again, I've got to play 7th grade math. So how am I going to write that? All right, how do I write it as an exponent? Is it 2 over 3 or 3 over 2? It's 2 over 3. This is always the denominator. Okay? So now, can't you take the 2/3 and bring it down? And then you're going to have an x. And then 2/3 minus 1 is going to give me a negative what? 1/3. Now this one shouldn't be a problem, except I've got to rewrite this one. How am I going to rewrite 1 over x? That's going to be x to the what? Is that going to be an x to the -1? We've got to get those algebra skills back up. Because when you bring something from bottom to top or top to bottom, it changes the sign on the exponent. Now I can go do the derivative. I don't touch numbers in front. What's the derivative cosine of an angle according to that rule over there? Negative sine of that. Minus Then that -1 comes down, my variable stays the same. What's a -1 minus 1 more? Everybody with me? Now, here's one more rule I want you to write on your paper. It's everybody's favorite. The derivative of e to the x is itself. That's why it's everybody's favorite. Now, where's your homework gonna be? On Moodle, but realize you're probably going to have to play a good bit of algebra before you even start the calculus part. Okay? Come see me if you need some help.